All right, so question 1, 4b take 5 equals negative 12. So here we've got A. I'm going to add 5 to each side. Add 5 to negative 12 becomes negative 7. Divide by 4. Negative 7 over 4. 5 minus 3a less than or equal to negative 1. Shouldn't hear lots of voices, just mine. Subtracting 5 from each side, I'm going to get negative 3a is less than or equal to that negative 1. My OneNote is playing up, so you should enjoy this, watching me get frustrated. It's kind of entertaining. Subtracting 5, we get negative 6. I'm about to divide by negative 3, aren't I? What's the one thing I need to remember when I'm dividing by a negative? Change the direction of the sign. A is greater than or equal to, you weren't the only one groaning, but I'm glad you felt it. Negative 6 divided by negative 3, 2. A is greater than or equal to 2. Question C. Oh, let's just join straight on from there. Why not? Oh, I'm loving this. Nothing nice to do here but expand first. So negative 3 by 4. Negative 12 plus 15x. Oh, my goodness. Is the other one any better? I might have to in a second. Minus 5x. Well, this one's working better. Minus 10. Thank you. I can go through all three. Equals negative 7. Oh, that's a little bit nicer. Okay, collect my x's together. 15x minus 5x is 10x. Negative 12, take away another 10. Negative 22 equals negative 7. Add 22 to each side. 10x equals positive 15. Divide by 10. X equals 3 over 2, or 1.5 if you like those ugly decimals. Which you do not, correct. Good, well said. I heard the nod at the end, even though you were trying to say it quite silently. 2x plus 1 divided by 3 minus 3x divided by 4 equals negative 2. I think this was about the first lesson of the year where I tried to impress this upon you. I'm going to go through it again, though. What's the best way to deal with these ones? You want to get rid of that denominator as quickly as possible. I'm going to multiply by 12. That's going to make my life easier. Multiplying by 12, the 3 is going to cancel in that first term, and I'm going to be left with 4 times 2x plus 1. You can either write it, or you can just do it. 4 times 2x is 8x. 4 times 1 is 4. With the second term, negative 3x over 4, when I multiply by 12, the 4's cancel, and I'm left multiplying by 3. So negative 3x times 3, negative 9x. Negative 2 by 12, negative 24. And we're nearly there, aren't we? On the left-hand side, I'm going to be left with negative x. I'm going to subtract that 4 because I don't want it on this side. So I'm going to have negative 28. Well, that must mean x equals 28. Sub it in and check it. You should be able to get an answer. 57 divided by 3, what's that? 19 minus 21. Yeah, negative 2. Happy. Well, you haven't told me what x is equal to, so I'd cry. Well, you just finish it off. Correct it now. Just pretend that never happened. We don't want that to happen, do we? If they're asking you to find x, not just... Oh, there you go. All right. 2 to the x plus 1 equals 64. Remember I said there are some numbers you need to recognize as powers. 64 as a power of 2. You might not know it's the 6th power, but you can do it on your fingers quickly enough, can't you? 2, 4, 8, 16, 32, 64. Oh, I'm up to my thumb. That's 2 to the x plus 1 equals 2 to the power of 6. Therefore, x plus 1 must equal 6. X is equal to 5. And you're done. All right, insert a bit of space here, and we are on to question 2. Using these points, find the equation to line AB. That's my first bit. Okay, so we need two things. We need a gradient. Change in y divided by change in x. 8 minus 3 divided by 5, take 2. The gradient for AB is equal to 5 over 3. Y equals 5 over 3x plus c. I'm not interested in that. I need to know that y-intercept. How am I going to do that? I'm going to substitute in one of the particular points. I can substitute in A or B. I don't care. Okay. Dry stream is already running. That's nice. I'm going to sub in 2, 3 to solve for C. So y is 3. That's equal to 5 over 3 multiplied by 2 plus c. 3 equals 10 over 3 plus C. You subtract 10 thirds, which is 3 1/3, and I've got negative 1/3 equals C. So Y is equal to 5 over 3x minus 1/3. Or if you wanted to, you could write it as 5x take 1 all divided by 3. That'd be fine. You could have 3y equals 5x minus 1, but we don't usually write it that way. Find the gradient of the line perpendicular to BC. Well, the first thing I need to do is find the gradient of BC. Changing y divided by changing x. I'm going to actually do I'm going to do b minus 8 minus negative 4. The coordinates of b minus the coordinates of c, and then 5 minus negative 1. So if I want the perpendicular gradient to BC, it's the negative reciprocal, negative 1 divided by 2.
All right, guys, make sure to mark this
Part C, the length of line segment AC, it's just our distance formula, isn't it? Difference in x coordinate squared plus difference in y coordinate squared. If you can't remember that, it's just Pythagoras' theorem. So we can remember Pythagoras' theorem. That works fine as well. So I've got A, filling in the blanks here. I'm going to go for the A points first. So 2 minus negative 1 squared plus 3 minus negative 4 squared. So 3 squared is going to be 9, and 7 squared is 49. D is equal to the square root of 58. Is there a perfect square that's a factor of 58? I don't think so, because it's 2 times 29. What's the decimal? No one cares. Yeah, decimals are disgusting. It's about 7.7-ish. I don't know. Check it. There you go. No, yeah, you can write units if you want. That makes me happy. I like that. Good. But not so much the ugly decimal. Oh, you used the wrong point? Well, just give yourself an uppercut and then move on. Life's okay. Don't do that in the actual exam. You don't have to give yourself an uppercut. You can just choose the person next to you if you'd rather. Well, I'm also next to her. But that, maybe you don't want it to hit me either. That's sweet. Oh, you can do it a slow, boring way. I'm just trying to make you happier. Save you time. All right. Simplifying without a calculator. A, what are we going to have here? 3 to the power of 4 by 3 to the power of 5. 4 and 5 make 9. Plus negative 2 makes 7. Plus 3 make 10. 3 to the power of 10. It says simplify, not evaluate. I don't know 3 to the power of 10 off the top of my head. That gets a little bit too big for me. B. Okay, B might be a little bit interesting to have a look at. All right, there are a few ways to go about doing this sort of question. It's a little bit annoying because they're not all nice. Ideally, what you want to do is get each number written in terms of its prime factors, because that's then going to make it easier. We can just work in the prime factors. You remember doing factor trees back when you were little kids, and we used to go something like 12, that's equal to 2 times 6. Oh, 6 is equal to 2 times 3. So 12 is actually 2 squared times 3. Remember doing those little factor trees? 8, we know that that's 2 to the power of 3 already. 6, we know that that's 2 times 3. 36, I can write as 6 squared, so it's actually going to be 2 squared times 3 squared. And 16 is 2 to the power of 4. So I can rewrite all of these numbers in terms of their prime factors. So I'm going to have 2 squared times 3 instead of 12, all to the power of 3. 8 is 2 to the power of 3, all to the power of 4. 6 is 2 times 3, all to the power of 3. 2 to the power of 4, all to the power of 4. Wow, what's this going to go to? 2 to the 6 times 3 to the 3 times 2 to the 12 times 2 to the 3 times 3 to the 3. 2 to the 4 times 3 to the 4 times 2 to the 16. Simplify the top and bottom separately. It's going to make your life a little bit easier. 18, 2 to the 21, 3 to the 6 over 2 to the 20 times 3 to the power of 4. Oh, that's 2 times 3 squared. And we can get to 18. Not the only way to do it. I can hear by the chit chat that we've all tried different things. That's okay. Hopefully we were able to get to that. Whichever way you did it, that's fine. You got something different? What, did I do it the wrong way? Maybe. We can check it again. That's what I get. We'll go back and find a mistake if I found one later on. Okay, well, we can pause and check it now. It's going to let me scroll eventually. Or not. Well, we'll have left to do if it actually lets me scroll. Let's close it down, open it up again. Oh, and there we go. That worked like a charm. All right, part C. Complex unfamiliar, they reckon. 6 to the power of m plus 1 times 8 to the power of m minus 1. I guess it's just a matter of questioning what you call simplified and what you call not simplified. Let's use the same principle we just used before. 6 I'm going to call 2 times 3, power of m plus 1. 8 I'm going to call 2 cubed, m minus 1. So I've got 2 to the power of m plus 1, 3 to the power of m plus 1, multiplied by 2 to the power of 3m minus 3. 3m plus another m is 4m, and 1 minus 3 is 2. So 2 to the power of 4m take 2, 3 to the power of m plus 1. We can argue all day about whether that's more simple or less simple. But there you go. That's in its simplest form, in the lowest powers, lowest base numbers, which is probably important. You can put a time sign in between. I probably don't need one with the powers there, but it's not wrong if you do. Oh, we're getting up to the funny one. Yeah, B. All right, 2 equations to solve simultaneously here. I'm looking at it. It's not set up for substitution. I'm going to go with elimination. So I'm going to multiply the top equation by 3. That's going to give me 9x take 15y equals negative 36. I'm going to multiply the bottom equation by 5. That's going to give me 10x plus 15y equals 5. And we agree so far. 9x minus 15y. I'm going to add those two things together because that's going to make my life easier again, isn't it? Sort of. 10x plus 9x is 19x. Negative 36 plus 5 is negative 31. X is equal to negative 31 over 19. Everyone's happy looking at those two beautiful prime numbers and substituting them back into something. I'm going to go with equation 2. Let x equal negative 31 over 19 in equation 2. So 2 times negative 31 over 19 plus 3y equals 1. It's not pretty. I'm probably going to multiply by 19 at this point just because it's going to get rid of that denominator, and I don't like having the 19 there. You don't have to. You can just go negative 62 over 19, add it on. and then you're going to have to create 19s anyway. I'm going to get rid of it, and then I know it's going to come back in the end, but I think in the meantime. Multiplying by 19, it cancels in the first term, so I'm just left with negative 62 plus 57y equals 19. That wasn't too painful. 57y equals, I add 62, I get 7281. 57y equals 81, y equals 81 divided by 57. We can simplify in this case, can't we? What do we simplify that down to? 27 over 19. Boom. I'm guessing you just probably forgot to get rid of a negative somewhere. The reason I know, and this is good, substituting these numbers in to check you're working would be difficult, right? Listen, this is a hot tip for everyone. Substituting in these fractions is going to be difficult if it's on a non-calculator exam. But if I'm looking at 2 times x plus 3 times y equaling a positive number, and I know that one of them is negative, the other one won't be able to be negative as well, or I'll end up with 2 negative numbers adding together to equal a positive. So that's a little clue. So you can still check without having to substitute in and figure out exactly. You can still check and just say, oh, I wonder if I just got a negative wrong somewhere. Go back and have a look, and that'll be all it is. You probably just misread something. But the x is negative 31 on 19. Oh, that's positive, yeah. But you got this. You don't leave it as negative 27 over negative 19. A negative divided by negative is a positive. It's like I don't say if I ask you how old you are and you are 15, yeah, you don't say I'm negative 30 over negative 2, sir, because that would be weird, wouldn't it? You say, oh, I'll write it nicely for you. I'll call myself 15. So yeah, just write it nicely. That's all it's saying. Now, it's good that we started. Yeah, you should. How old are you? Oh yeah, negative 30 over negative 2. The good bit is, while we're talking on weird ways of doing things, let's have a look at the father and the son. I'm going to let f equal the father's age and f equal the son's age. We're going to write these equations. 2 times the son age added to the father's age. And then the second one, and then it's the son plus the father equals 95. This is set up for elimination. I'm going to do subtraction here. Equation 1 minus equation 2. The son is yet to be born. He is negative 25 years old. He's going to be born in the future. Oh, it makes perfect sense. You know, if the year was, so you were born in 2005? 2005. So in 1980, how old were you? Oh, who doesn't plan having a child then? I would have been in grades. I would have been 7 years old. I would have been thinking about when I was going to have my third child. Makes perfect sense. Ah. And so the father's age is just a relatively young 120. Yeah, relatively young. Yeah. You know. Okay, so maybe this is on a planet with really short years where they spin around quickly. Yeah, a small orbit. Sorry? Oh, so it worked okay for you. All right, if you get something like that in an exam, chances are something has gone wrong. Because in an exam, I will hopefully get it right and make sure that the people would be of appropriately sensible ages. Oh, I didn't write that one. But that would have come from someone else. You will get used to the fact that sometimes they just come out quickly. That's just for our entertainment's sake. We can still do the maths. That's what we're worried about. All right, we've only got a few minutes left. We're going to have to crank up the speed here a little bit. Cloud is selecting at random from a standard deck of cards. Find the probability of selecting a red ace. 2 out of 52. Red ace equals 2 out of 52, which is 1 over 26. B, probability of getting a 4 or a spade. Oh, that's just terrible. There you go. That looks slightly more spade-like now. No, it never looked like a spade to begin with. Okay, be careful with this one. So, there are 4 spades out of the 52. There are, 4 fours. There are 13 spades, but one of those spades is the 4 of spades, so we've got to take away 1. 17 minus 1, 16 over 52. We're not going to leave our answer like that. We're going to write it as 4 over 13. Done. Part C, a 10 or a black card. So I have 4 10s, 26 black cards, but I've counted 2 of the black 10s twice. So we're going to take away those 2. So I end up with 28 out of 52, which is going to give me 7 over 13. Nice job. 6, sample space for tossing a coin 3 times. List the sample space. So the sample space, it happened about 7 times in my last class, so this hasn't been too bad. So the sample space is what you get at the end of each of those branches of the tree. Probability of 2 heads and 1 tail. 1, 2, 3. 3 out of 8. All tails, 1 out of 8. Oh, we're cranking it up here. Expand the following. X squared. You could put this extra line in between where you go plus 3x minus 2x, but I'm just going to do that in my head and go plus x minus 6. Done. That was not a difference of 2 squares. That's coming up. Yes, hold your horses. Yeah. 6a squared. I'm going to end up with 4a minus 3a is plus a minus 2. A squared minus 9. Favourite rule in maths, difference of 2 squares. X squared plus 10x plus 25. It's a perfect square. It's what we try to create when we are completing the square. This one here, that is not complex, unfamiliar. He's being far too generous there. 4m squared minus 2 times 2m times 3. I'll write the extra step in between. Plus 3 squared. I'll even go back and change that one to 2m. 4m squared minus 12m plus 9. Oh, it says cubed. Hey. Oh, forgive him. That's all right. So I'm showing you how to do it the long way. So if I'm trying to do this cubed, I just do the first bit. I square the first 2, leave the third one alone, then I expand further, right? So I'm going to have 8m cubed minus 12m squared, minus 24m squared plus 36m plus 18m minus 27. Yeah. Yeah, we'll get through it this time. All right, and there you go. So cubing. Interestingly, if you want to know the shortcut way to do that, a cubed plus 3a squared b plus 3ab squared plus b cubed. If it was minus, so you'll need those next year. If you write them down now, it'll save you having to learn them next year. We can actually do that expansion for any power. So there'll be a pattern for powers of 4 and 5 and 6, and we'll show you how to work that out next year. If you want to see it before then, you can ask me sometime. It's not very hard. You can all definitely do it. How do I follow that rule? 2m all cubed, yep, that would give me 8m cubed. 3 times 2m squared would be 3 times 4 is 12m squared times negative 3, negative 36m squared. You can see we get the same answer. Oh, draw two diagrams showing all the exact values for sine, cosine, and tan of 30, 45, and 60. Yeah. Best friends, little buddies. That's it. Can't go wrong. We just want you to remember those. You've got a best friend in maths. You've got to remember your best friends, little buddies, don't you, Kate? Oh, no. You can draw a table, but it's so much easier to draw that and then draw the table. That's a diagram. That shows it too, yeah. There are other diagrams. No, that's fine. There are other diagrams. You can show it on your unit circle. You show different things. Well, that's different parts on the one diagram, so that's a little bit fancy. Yeah, that's two different diagrams. It doesn't really matter. As long as you've got a way of knowing them, and that's the way we suggest you remember them, that's what we're after. Yeah. All right. Sine of 150. Now, pay attention here, guys, because I know that one of the sections that we're going to have to go over in these couple of weeks revision we're going to have after this week is going to be unit circle stuff, and this is unit circle stuff. So make sure you watch the procedure for finding the exact value for sine 150 in case you haven't got it from when you were working at home, which is fine, but for some of us we're going to need a little bit of a hand here. So whenever I'm given the sine of something to calculate, first thing I want to do is I want to draw a diagram. And I go to my best friend and I say 150 degrees is over here. How far away from the closest x-axis is that? 30 degrees. And then I ask my best buddy, oh, the sine value, that's the y-coordinate, isn't it? Are the sine value is going to be positive or negative in that quadrant? And he says, well, just go across and read off my axis. It must be positive. Oh, so sine 150 is the same as the sine of 30. Who do I ask if I want to know the sine of 30? Best friends, little buddies. Sine of 30. Opposite 1, hypotenuse 2. 1 over 2. Oh, they'll always be between negative 1 and 1. So, because it's a unit circle. Okay, cosine of 225. Let's watch that procedure again. And of course, that's when my pen decides to not work. All right. Cosine of 225, I draw where it is in the unit circle. And it's 45 degrees away from the closest x-axis. So I know it's going to be, the size of it's going to be equal to cosine of 45. Is it going to be positive or negative? Now, I showed you the first way to do it. You just say, oh, cosine's my x-coordinate, read up to the x-axis, it's to the left, it's negative. Or you remember your little mnemonic. Oh, come on, pen, hold it together. All right, here we go. Try the fancy one. All students, oh yeah, that's easy. All students take crack. Oh, only tan is positive in the third quadrant. So cosine must be negative there. Oh, and it's larger too. No, it's great. I'm going to go steal one. Bit light. Cosine of 45, best friend's little buddy, it's going to tell me 1 over root 2.
Okay, quick question. Who left their answer as 1 on root 2? Negative 1 on root 2. Come on, now, did you leave it there?
Oh, did I see a hand in the air?
You're losing your final mark. What should you do when there's a third on the bottom? What's that word?
Yeah.
Yeah, we should rationalize, so we should multiply by root 2 on 2. Root 2 on root 2. So give yourself a mark, but remember your exam. I need to rationalize. Root 2 on root 2. Yeah, that's how it's all. And the other time you can get it is when you change it. So that's when
That's the secret. You got to find the reference angle. Yeah, how far away from the closest x-axis am I? Tan of 330. Yeah, easy. So it's 30 degrees. This is equal to, in that quadrant, tan is negative, so negative tan 30. Tan of 30 degrees, you go to your best friend's little buddy and you say, oh, that's 1 over root 3. Negative 1 on root 3, negative root 3 on 3, gold star. Nearly there. Oh, last question. Okay. These are still going to be unfamiliar questions in grade 11, but I expect you all to be able to do them because they're actually pretty easy. Well, I'm going to teach you it right now. So, unfamiliar in the sense that it's not standard. So some people struggle. The way to do these questions, the negative is just referring to which quadrant I'm in. But I can still draw the triangle that would reside in that quadrant. Now, it's got to go down 3 and across 4. So it's going to have coordinates. So that's going to be down 3 and across 4. I can draw an equivalent triangle. You just draw any triangle with an angle, opposite side 3, adjacent side 4. Can we find do arctan of 3/4, so the inverse tan button on your calculator? That's going to tell me what theta is equal to. Now, someone else is going to have to do arctan 3/4 on their calculator because I don't have one here.
What do we get in degrees, guys?
Sorry? 36.87? Nah. Okay. So, I have only found, what I should really be doing is writing, because they actually gave me theta. I'm going to put an alpha here. That would be nicer, wouldn't it? So then, tan theta, theta is 360 degrees minus that 36.87 degrees.
Because the question tells you you are only interested in a solution between 270 and 360, which is quadrant 4. So you've basically found your reference angle. You know how you've generally been using reference angles of 30, 60, or 45? This has a reference angle of It's just not one you know from your exact triangle. What you need to do then is say, well, my reference angle that I found from my calculator is 36.87. I need to now find out, well, what is the equivalent angle then in quadrant form? So to do that, you're going to do, because it's just below the 360 degrees, you do 360, take your 36.87, and that gives you your angle theta, which is the correct solution for this problem because of what we call the domain, which is the 270 is less than theta, which is less than 360.
So if you type in on your calculator to check, tan of 323.17. Oh, 0.13 was it? Oh, I wrote 17. Huh. Yeah, it is 113. Absolutely.
So if you type that in, you should get negative 0.75.
We get 0.75? Is it close? If you do that on your calculator, because we round it off a little bit. On the calculator, do tan of 323.13. Yeah, close enough.
All right, guys, listen up. So who needs to make sure they get their work uploaded by tomorrow?